Okay, so here's a lesson for section 5.5, first differences. In this lesson, what we're going to hopefully be able to do by the end is be able to look at a table of values. So I've got a table of values with a bunch of numbers in the x column and the y column. I want to be able to look at this table of values and state whether the data in this table forms a linear relationship or some other type of nonlinear relationship. And we're going to be able to do that by calculating the first differences. Before we actually do that, I just want to go through a quick example looking at a table of values, looking at the graph of the table of values, and kind of comparing how you might be able to tell without graphing the data whether it'll form a straight line or not. But before we can do that, let's actually graph a table of values and see if it forms a straight line. So here's the question. If a tennis ball falls out of a third-story window of a building, will its motion be linear? So that's the key question we want to solve here. Will the motion be linear? In order to do that, we don't know how to calculate first differences yet, so I'm going to have to graph the relationship to see if it represents a linear motion. So time is in the left column, so that's my independent variable x. Height is in the right-hand column, that's the dependent variable y, and it makes sense because height depends on the time, okay? So the height of the ball depends on the amount of time it's been falling for. So I've got the time on the x-axis, or on the, time is on the x-axis. Where'd my cursor go? There it is. Okay, so time, horizontal axis, independent variable always goes on the horizontal axis. Height is on the y-axis because the dependent variable always goes on the y-axis. And my scale is already done for, so I've already labeled the axes. Let's plot the points. So when time is 0, so before the ball is started to fall, it is at a height of 30 meters, so my initial value is at 30 meters. That means the y-intercept is at 30. After the ball has been falling for 1 second, the height now goes down to 29 meters. So it's roughly about here. After 2 seconds, I believe it goes down to 26. After 3 seconds, it's down to 21. 3 seconds, it's now at 21. After 4 seconds, I saw it went down to 14. At 5 seconds, it was all the way down to 5. And then after 6 seconds, it says it was on the ground. So if I look at the trend in the data, I don't think it hit the ground exactly at 6 seconds. It looks like it hit the ground probably sooner. If I draw a curve of best fit through these lines, I'll do my best to do this. If I draw a curve of best fit through these lines, okay, I can see clearly this does not form a straight line, okay? This data clearly shows some type of nonlinear relationship because they clearly do not follow a linear graph. Okay, I could not draw a straight line through all of these points. This is not a linear relationship. This is clearly some type of non-linear relationship. We're not too concerned about what type of nonlinear function this is yet. We just want to make sure we understand this is not a nonlinear function. Okay, you might be able to tell this from the table of values. Okay, let's think about how could we figure out without graphing this that this is going to form a nonlinear function. Okay, and we might be able to tell this by, let's take a look. So on the left-hand column, my independent variable. So my x values, they're all evenly spaced. So I go from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. That's good. You want your x values to be evenly spaced so you can accurately compare the y values. See how the y values are changing as the x variables are increasing by constant amounts. Okay, so that's good. X values are increasing by 1 each time, so they're evenly spaced. That's good. Now let's look at how the y values are changing. So from the first y value to the second y value, okay, it's gone from 30 to 29. It's gone down by 1. Now let's look at the next two y variables. So from 29 to 26, okay, it's now gone down by 3. The next ones, from 26 to 21, it's now gone down by 5. From 21 to 14, it's now gone down by 7. From 14 to 5, it's now gone down by 9. And then it hits the ground before we get to the next one, so I'm not going to compare the next ones. But look at these values. See how it's changing by 1, then 3, then 5, then 7. It's changing by increasing amounts each time. It's not changing by the same amount, so it's not going to follow a straight line. The amount that it's falling is increasing every single time. That's why we get this curved looking graph here. Okay, so that's why we get the nonlinear function. And you might want to think, okay, why why is it not a constant rate of change? Why does it seem like this ball is accelerating towards the ground? Well, it's because of the acceleration of gravity. So the gravity is pulling the ball to the ground at an accelerated rate. That's why the speed is increasing as the time is increasing. Okay? So now you might be asking, okay, so if a nonlinear graph, the table of values, the y values are increasing at a non-constant rate, let's just quickly look at what would the table of values look like for a linear function. So I'm just going to erase all this data here if I can. Hopefully this won't take too long. Okay, let's say this is my new table of values. So once again, when time is 0, the ball starts at 30 meters. Let's say that happens. Then let's say after 1 second, it's now down to 25. Okay? So it's now down to 25. And then I'll keep going with my table of values. Then let's say it keeps falling at a constant rate. So it fell by 5 in the first second. Let's say it falls by another 5 the next second. Then another 5 the next second. Then another 5 the next second. So it goes 20, then 15, then 10, and so on. If I connect all these lines, you'll notice that this, in fact, forms a straight line. And that straight line occurs when, so if this one falls by 5, between these two, it fell by 5. Between these two, it fell by 5. Between these two, it fell by 5. So when the changes in the y values are all constant, okay, that's when it forms a straight line, assuming that the x values are evenly spaced. That's important. Okay, so in this case, we have a constant rate of change. Therefore, we have a straight line. Straight lines always have a constant rate of change. That's why we call the m value in y equals mx plus b. That's why sometimes we call it a constant of variation, because it's required that this change of the y values divided by the change in x is going to be constant every single time. Okay? So let's recall, we know that from graphing lines that if the slope is constant, okay, so look at this line, the slope to get from this point to this point, the slope is we go down 5, right 1, so the slope is negative 5. To get from that point to the next point, we once again go down 5, right 1, so the slope is negative 5. Once again from this one to this one, down 5, right 1, so the slope is negative 5. So the slope to get from each point is constant, okay? That means the relation will form a straight line. If the slope is not constant, it will not form a straight line. It will be some other type of nonlinear function. So remember, slope equals rise over run, which equals, I don't know why this is change in x over change in y. This definitely should say change in y over change in x. I'll make sure I fix that after I finish recording this. Okay. Remember, rise over run. Rise is the vertical distance between 2 points. Vertical is always y, so change in y. Run is the horizontal distance between 2 points. Horizontal axis is x, that's why it's change in x. Okay. So therefore, if we know straight lines have a constant slope, okay, and we know slope is change in y over change in x, we need to determine if the changes in x and y are constant in a table to determine if the relation is linear. Okay, so let's look at what are first differences. First differences are the differences between consecutive y values and tables of values with evenly spaced x values. This is important, evenly spaced x values. You cannot calculate first differences if your x values are not evenly spaced. If the first difference of a relation are constant, like we looked at when I made my own table of values here, when the first differences were constant, so I had negative 5. Oops. So when I calculated my differences here, I got negative 5 for each of them. Okay. When I calculated my differences in the y values, that meant that it was a linear relation. In the first example that I did, when the first differences were not constant, it was accelerating as it was falling. So it fell by 1 meter in the first second, then 3 meters the next, and then 5 meters the one after that. Okay, so when it was accelerating, when they were not constant, the relation was nonlinear. So if first distances are constant, the relation is linear. If first differences relation are not constant, the relation is non-linear. Okay, so here's an example that's been done for you. I've given you the table of values, so I'll give you this part, the table of values, and I'll ask you, does this form a linear or a non-linear relation? So first thing you need to do before you even calculate the first difference is you need to look at the column with the independent variable, the x. Okay, you need to make sure, notice that the x values change by a constant amount. That's the only way you can calculate your first differences is if the x values are evenly spaced, if they're increasing by a constant amount. In this case, they're going up by ones each time. It goes from 0 to 1, 1 to 2, 2 to 3, and so on. So they're going up by a constant amount, so we can calculate the first differences. Now that you've determined the x values are evenly spaced, now you can kind of forget about that column and just concentrate on your dependent variable, the y column. Now we want to look at the differences between the y values. So we're going to look at the differences between the first two. So it goes from 0 to 3. So let's find the difference. You do the second one minus the first one, 3 minus 0, the difference is 3. Now look at the second and the third y values. So it goes from 3 to 6, so the difference is 6 minus 3, which is 3 once again. Then look at the next two. It goes from 6 to 9, so that difference is 3 again. And then the next two, it goes from 9 to 12. The difference between 9 and 12 is 3 again. So you'll notice that the differences between the consecutive y values are constant. So it's going up by 3 each time, from 0 to 3, 3 to 6, 6 to 9, 9 to 12. Those are all constant. Okay, this means that it is a linear relation. Because the first differences are all constant, it is a linear relation. So I'm going to give you some table of values, and you're going to practice determining if it's linear or not. And we're going to start off. I'm just going to give you the equation, and you're going to make the table of values. And that way you'll be able to see the relationship between what the equation looks like and whether it's going to be a linear relation or not. Okay. So the first equation I have here, I have y equals negative 2x plus 7. So when x equals 0, what does y equal? Well, let's figure that out by plugging in 0 for x and solving for y. Negative 2 times 0 is 0. 0 plus 7 is 7. So when x is 0, y is 7. Okay? Now, oops, I erased the 7 by accident. So when x is 0, y is 7. Now let's figure out when x is 1, what does y equal? Well, plug in 1 for x and solve. Negative 2 times 1 plus 7. Negative 2 times 1 is negative 2, plus 7 is 5. And you could finish off this table of values, and I encourage you to finish this off yourself now, so I would pause it right now and just finish it off. And then what you should have got, after you finish this off yourself, when x is 2, you should have got y is equal to 3. When x is 3, plug in 3 for x and solve, you get y is equal to 1. When you plug in 4 for x, you'd get negative 2 times 4, which is negative 8, plus 7 is negative 1. Okay? Now that you have your table of values completed, now what I would do, I would actually, I don't want to erase all of that. Now that you have your table of values completed, you want to make sure that your x values are evenly spaced. So make sure your x values are increasing by constant amounts. So my x values go from 0 to 1, 1 to 2, 2 to 3, 3 to 4. So those are evenly spaced. They're going up by 1, so that's good. So now I can calculate my first differences. So I want to find the difference between the y values, between the first two. So it goes from 7 to 5 to find the difference. Do the second one minus the first one. 5 minus 7 equals negative 2. Then look at the next two. It goes from 5 to 3, so find that difference by doing 3 minus 5. That equals negative 2. Then look at the next pair. It goes from 3 to 1. So calculate the difference between 1 minus 3, negative 2. And then the last two, it goes from 1 to negative 1. So find that difference between negative 1 minus 1. That equals negative 2. So my y values go from 7 to 5 to 3 to 1 to negative 1. So they're going down by 2 each time. That's why I've calculated my first differences to be constant at negative 2, because they're going down by 2 each time. If when you calculate your first differences, if you get the same number for each difference, so if the first differences are constant, okay, the first differences are constant, Therefore, the relationship is linear. If you were to graph all of these points, they would form a straight line. Let's look at the next equation, y equals x squared. So if x was 0, 0 squared equals 0. So y would be 0. If x was 1, 1 squared is equal to 1. If y was equal, if x was equal to 2, 2 squared is equal to 4. So y would be 4. If x was equal to 3, okay, and we know y equals x squared, so y equals 3 squared, y would be 9. If x is equal to 4, 4 squared is 16. Let's calculate our first differences, but before we do that, make sure your x values are increasing by constant amounts. So look at the x column, it goes from 0 to 1, 1 to 2, 3 to 4, or 2 to 3, sorry, and then 3 to 4. Good, those increase by constant amounts. Therefore, we can calculate our first differences. Let's check what the y's are changing by. So it goes from 0 to 1. So calculate the difference. 1 minus 0 equals 1. Then it goes from 1 to 4. Calculate the difference by doing 4 minus 1. So the difference is 3. Then it goes from 4 to 9. That difference, 9 minus 4, is 5. Then it goes from 16 to 9, or 9 to 16, sorry. Calculate the difference by doing 16 minus 9, so it increases by 7. So you should notice here, the first differences are not constant. They're not the same numbers each time. The first time it goes from 0 to 1, so it increases by 1. Then 1 to 4, it increases by 3. Then 4 to 9 increases by 5. Then 9 to 16 increases by 7. So they're not constant. Therefore, it forms a nonlinear relation. I don't need you to know that it forms a quadratic relation. I just need you to know that it is a non-linear relationship. Okay? So if the first differences are not constant, so these are definitely not the same number, 1, 3, 5, and 7 are not the same number, okay? So that means it's a nonlinear relation. In the first example, they were the same number, so it formed a linear relation. If you want, you can do the next one on your own, okay? And just to see whether this function here, y equals 2 to the x, forms a linear relation or not. But I'm going to skip that one for the sake of time for this lesson. Okay, let's just check your understanding quickly, just to see. I'm going to give you the table of values. I'm going to give you a completed table of values, and you just check to see if it forms a linear relationship or not by checking the first differences. So remember step number 1, check the x column, see if they increase by a constant amount. They go up by 1s. So that's good. So I can ignore that, and now I just want to look at the differences between the y values. So the y values, what are the y values changing by? So between the first two, it goes from 7 to 3. So we'll find the difference by doing the second minus the first. I get negative 4. Then it goes from 3 to negative 1. Find the difference. It's negative 4. Then it goes from negative 1 to negative 5. Find the difference. Negative 5 minus negative 1. That means negative 5 plus 1, which is negative 4. And then it goes from negative 5 to negative 9. And find the difference between those. Negative 9 minus negative 5. That means negative 9 plus 5, which is negative 4. And you'll notice that these are all constant. So the constant of variation here is negative 4. Okay, because the y values, it goes from 7 to 3, 3 to negative 1, and so on. It's going down by 4 every single time. That's why I calculated the difference to be negative 4 every time. So the type of relation, since these are all the exact same number, it's a linear relation. Let's look at example 5. So once again, start off, if it's going to ask you, is this a linear relation or not? First step, look at the x column, make sure they're evenly spaced, and in this case they are. It's increasing by 1 each time, from 2 to 3, 3 to 4, 4 to 5, 5 to 6. So I can now just concentrate on the y column and make sure these are evenly spaced as well. Okay, so find the difference between the first two to start. So it goes from negative 5 to 10, so find the difference. 10 minus negative 5, that means 10 plus 5, so that's 15. Then find the difference in the next two. It goes from 10 to 25. Find that difference. 25 minus 10, that's 15 as well. Then find the difference in the next two, from 25 to 40. Find that difference. 40 minus 25, that's 15 as well. And the last pair goes from 40 to 55. Find that difference. 55 minus 40, that's 15 as well. Since these are all constant, these are all the same number, it forms a linear relation. Last example, once again, when you're given a table of values and it asks you to calculate first differences, first of all, make sure your x's are evenly spaced, and they are. They're increasing by 1 each time. So now we can just concentrate on our y column and calculate the first differences between each pair of y coordinates, each pair of y values, and make sure that the difference is constant each time. So let's look at the difference between the first two. It goes from -10 to -2. So find the difference. Doing the second minus the first one, so -2 minus -10, that means -2 plus 10, which is 8. Then find the difference in the next two. It goes from -2 to 0, so find the difference by doing 0 minus -2. That means 0 plus 2, which is 2. Then the next two from 0 to 2, the difference, 2 minus 0 equals 2. And then the last set, it goes from 2 to 10. Find the difference between 2 minus 10 equals 8. So once again, these numbers here are not constant. I have an 8, a 2, a 2, and an 8. That means it's not increasing or decreasing by a constant amount. Therefore, it's not going to form a linear relationship. So in this case, this forms a non-linear relation. So just quick summary of the main thing you need to understand. You need to understand that that we know from graphing lines that if the slope is constant, then the relation will form a straight line. So if you calculate first differences and the first differences are constant, the relation is linear. If the first differences relation are not constant, then it's nonlinear. Okay, so make sure you go to jensenmath.ca, download the worksheet, try it out, make sure you check your answers, and let me know if you have any questions.